Hello, my name is Jared Rose, and I'll be covering the question, is feral concurrency good enough? So wait, what is feral? We haven't really discussed yet at this point in the presentation what feral is, what it means. The authors use this term in the paper loosely for metaphorical reasons. In the literal sense, it's an animal in a wild state, especially after escape from captivity or domestication. But in the context of the paper, they mean it to say that it's an application level, application domain specific topic or concurrency in this case. So I have an example here in pseudocode of a read, check, update, save of this concurrency issue that can exist. So this example is a pickup truck that wants to be assigned a driver, or at least a driver that's looking for a pickup truck, and you want to pick a truck that's in the draft state and assign it a driver, and then save it to the database. But there's an issue with this that if this is done on two separate threads running at the same time, this can cause a race condition where two drivers are assigned to the same truck, say within 5 milliseconds of each other. The database doesn't handle this properly. This could happen by two clients requesting pickups at the same time from, say, a mobile phone app or something where they want to request a truck to their name, and it just happens to be that it hits that way at the server. So a good example to kind of correct this is to go with a more transactional approach, even with hundreds of these transactions, where you have specific update where clauses that will be formed whenever you execute this. The database will only ever return one row once. All the others will get 0 rows. You will not have duplicate rows whenever you check a particular truck, in this case, being assigned to two drivers to that truck. So what gets us in trouble here is that the save function here was the real culprit. Working with object drafts in memory and committing them versus having the database perform them transactions can cause this race condition. The ORM framework available to Ruby on Rails in this paper allows a much larger range of flexibility for developers, though. That's the catch. So the actual paper results that they reported, they used invariant confluence analysis to come up with a final number based on the total validations observed in the corpus survey of all the open source projects that they covered. And they declared that 86.9 of Rails validation usage by volume is actually safe under current execution. So what are we really asking with this question? Is the question being, is feral concurrency good enough? Is it really okay relying on just concurrency checks at the application level? The paper states that it is possible, in fact, that the degree of concurrency and data contention within Rails-backed applications simply doesn't lead to these concurrency races, that in some cases validations are good enough for many applications, so they just don't have the high level of traffic to where that would even affect them at all. But then the next line really reads in the paper right after that, nevertheless, in both cases, Rails feral mechanisms are poor substitutes for their respective database counterparts, at least in terms of integrity. So this is where I personally couldn't agree anymore. If I'm working with an application, I want integrity to be there, whether or not really the application allows for that kind of inconsistency. It's asking the application to do, at least in the context of this paper, it's asking the application to do one of the database's most fundamental jobs in keeping that integrity of the data. To me, integrity must be maintained in the data model. You cannot have duplicate truck drivers assigned to one truck, the same truck, at the same time. So currently, the ORM application approaches that exist in databases that they looked at, there's two of them. There's the ACID transactions, which was the good approach for that the good example approach that I showed you that preserves integrity, but it has the cost of performance in that it has to serialize all those transactions each time you do that. The custom Feral application level enforcement is performant. It's quicker most of the time than the ACID transactions, but it's at the cost of integrity under certain cases. So at this point today, application programmers lack an approach of ORM development that provides the right integrity, the proper integrity at the required performance for both the speed and the speed of execution and the programmability. The ORM frameworks provide you to mess and they let you modify objects right there in your code as if it's just another object in your application, and that is very powerful and flexible for programmers. That really speeds development time. The paper states in neither case does the database respect and assist with application programmer desires for a clean idiomatic means of expressing correctness, criteria, and domain logic. So to kind of round this back to the whole Feral, the literal meaning of Feral is the domestication aspect. That in the paper, the authors eventually state that their approach, they state their approach on how they plan to domesticate these Feral mechanisms that currently exist in all these applications that are trying to do Feral concurrency themselves. I just threw in the domestication definition in which it's to tame an animal and keep it as a pet or farm to produce or for farm produce. The authors say that with the proper database interface for these Feral applications, it would enable them to do three things: express correctness criteria in the language of their domain model with minimal friction while permitting their automatic enforcement. What that really means is that it allows them to respect the ORM application patterns and programming style that be in the database, including the ability to specify invariants in each framework's native language. The second thing that this interface would help with is it would allow applications to only pay the price of coordination when necessary. And that means that many invariants can be safely executed without coordination, while others cannot. The many that do not need coordination, the ones that should not need that coordination shouldn't be unnecessarily penalized, meaning that the checks that are unnecessary shouldn't be there. They shouldn't have to be ran, wasting execution time. And then the third thing is easily deployed to multiple database backends, which would preserve the existing compatibility that are there in current applications. And they think possibly by providing a bolt-on compatibility layer between ORM systems and databases lacking advanced functionality. So it would just basically, ideally, in their own mind, be able to replace the database system that's currently there without changing the application level logic, at least too much. And that's all for my part of the presentation.